There are 41 recognized species in the cat family when the domestic cat is counted on its own. You probably know 3 of them. That is not the strange part. The strange part is that long before true cats became established, other predators had already found the same shape: a short face, forward-looking eyes, quiet feet, a body that waits, folds, and releases. Evolution did not make one cat. It kept returning to the same answer. Once you notice the outline, it becomes difficult to stop seeing it. Start with the cats that are still here. At one end is the rusty spotted cat. It weighs roughly 1 to 2 kilograms and can disappear into dry grass that barely reaches your ankle. At the other end are lions and tigers, hundreds of times heavier. The difference is not just size. Evolution adjusted the legs, the tail, the paws, the ears, the coat, the habitat, and the method, but it kept returning to a familiar sequence: stillness, focus, compression, release. The black-footed cat hunts small prey through the night. In one widely reported field estimate, roughly 6 attacks in 10 succeeded. The serval listens through tall grass and jumps almost vertically onto animals it may never have seen. The flat-headed cat works along water and takes fish and other aquatic prey. The snow leopard uses a long tail for balance on slopes where one bad landing can carry it down a mountain. The cheetah traded much of the ordinary ambush build for speed. Its claws remain partly exposed. Its spine extends and folds through every stride. Even here, the animal is still recognizably a cat. The Andean mountain cat is seen so rarely that camera traps have done much of the watching for us. The marnal sits low against the step and waits until waiting becomes difficult to separate from stone. Different climates, different prey, different sizes, the same basic problem. Get close without being noticed, then move once. Seen separately, these animals look specialized. Seen together, the sequence repeats. The ears change, the habitat changes. The moment before movement remains recognizably the same. This is where the story becomes less tidy. Cat-like predators existed before the modern cat family took its present form. Nimravids are often called false cats. They were not members of Felidae. Their skulls and ear structures placed them on another branch of the cat-like carnivores, but many of them carried a familiar outline: a compact predatory head, forward-facing eyes, powerful forelimbs, a body suited to approaching from cover. Later came barbarophilids. Their exact family tree remains debated. Some researchers place them close to nimravids, others separate them more clearly. What is not debated is the visual result. Another branch had arrived at a cat-shaped ambush predator. This is convergent evolution. Different ancestry can produce similar anatomy when the animals keep solving a similar problem. A dolphin resembles an extinct marine reptile because water rewards a streamlined body. A cat-like hunter rewards something else: eyes that judge distance, feet that approach quietly, forelimbs that control struggling prey. A short jaw that closes with precision. The shape was never copied perfectly. It did not need to be, it only needed to work. Every living felid is an obligate carnivore. Meat is not simply what it prefers. Its metabolism depends on nutrients obtained from animal tissue. Cats can swallow grass or other plant material. That does not turn them into herbivores. The digestive system, teeth, and jaw remain committed to flesh. The extinct cat-like predators cannot be tested in the same way, but their teeth and skulls show animals built overwhelmingly for killing and processing other animals. The commitment was narrow. The scale was not. The same general hunting machinery could be used on a rodent, a bird, a fish, a deer, or an animal several times the predator's own weight. That flexibility mattered. The earliest animals generally recognized as true felids appeared around 30 million years ago. Proilurus was not one tiny founding cat. Several species are recognized. Some were around the size of an ocelot. Others approached the size of a lynx. Their bodies were longer and lower than those of many living cats. They were capable climbers and woodland hunters. The outline was already familiar, but it was not finished. Later felids spread and divided. One broad direction eventually produced the living branches called Feline and Pantherinae. Another produced the saber-toothed cats, the Machairodontinae. The split did not create a successful branch and a failed branch. Both survived for millions of years. Machairodus carried elongated upper canines and a body built to control large prey. Homotherium developed shorter, broader scimitar-like teeth and long forelimbs. Its fossils occur across several continents. Smilodon came later. It was not a tiger. It was a heavily built ambush predator with massive forelimbs, a short tail, and upper canines that could approach 28 centimeters in the largest forms. To clear those teeth, the jaws could open to roughly 95 degrees. That was far wider than the gape of a living lion. The teeth were effective, but they were not tools for biting into anything at any angle. The forelimbs first had to control the prey. The neck and jaw then placed the canines carefully. Thousands of Smilodon remains have been recovered from the La Brea deposits in Los Angeles. They preserve broken bones, healed injuries, and repeated evidence that these animals lived long enough for damaged bodies to recover. The fossils do not tell us every detail of their behavior. They do tell us that the saber-toothed design was not brief. It persisted through changing climates and ecosystems for a very long time. Near the end of the Pleistocene, the final saber-toothed cats disappeared. Climate changed, prey communities changed, humans expanded into new regions. The balance among those causes is still debated. A clean single explanation would be convenient. The fossil record did not provide one. South America produced an even stranger comparison. Thylacosmilus carried long upper canines protected by deep flanges on the lower jaw. It was not a felid. It was a marsupial relative on a branch separated from cats by a vast stretch of mammalian history. The skull was different, the jaw was different, the body was different, the weapon looked familiar. Evolution had found another route toward a saber. The living cat family is divided into real evolutionary branches. Big cats and small cats are not an invented distinction. Pantherinae includes the roaring cats and their close relatives. Feline includes pumas, cheetahs, lynxes, servals, caracals, wildcats, and many others. The branches differ. What remains striking is how much they still share. Forward eyes, sensitive whiskers, a flexible spine, grasping forelimbs, canines for puncturing, a cheek teeth shaped more for slicing than grinding. The clouded leopard moved the living felid design toward large canines and life in trees. The fishing cat strengthened its relationship with water. The cheetah became a pursuit specialist. The lion became social. The house cat moved into human settlements and found a new landscape filled with walls, furniture, windows, and small prey. The body plan did not prevent change. It gave change a reliable starting point. Look at a house cat beside a window. The animal appears small because the room is familiar. Its attention is not in the room. The eyes fix on movement outside. The body lowers. The hind legs gather beneath it. The tail may move once or remain completely still. The sequence is old, not because nothing changed, because the useful parts kept surviving change. Before true cats, other predators approached the same outline. Within the true cats, one branch carried the design toward sabers, another carried it into forests, deserts, mountains, wetlands, grasslands, and houses. Most of the old forms are gone. The problem they solved is still here. Approach quietly, judge the distance, wait, then move once. Right now, somewhere, a cat is waiting.